Okay, so the last topic we're going to do is it's not a new topic. It's actually just a modification of the calculation, and we already did it. We did it with example 3 with the water heater question. So it's called payback, and you can write at the top there. I suppose I should write it on the board. So payback period is it's really specific. It's you're solving for time, how long it takes to save money on an energy efficient calculation. But the cool thing about this time savings is your target amount of money, you want it to be the money that you actually spent to buy something that you're going to use. So this is where it's interesting. So you walk into the hardware store, you walk into Lowe's, you buy some energy efficient device, or you decide between two of them, one of them being energy efficient and one of them just the regular one that everybody else buys. And you spend some extra money to buy the better one. Well, that's what this calculation is. How long does it take to save the extra money that you spent? Because then theoretically, it's like you never did it. And every single energy efficient device is going to start saving money. So like every single one of these questions will pay itself off eventually. But the question is it a reasonable amount of time? Like 6 months later, you've paid off the difference, or a year later, you've paid off the difference? Or does it take like 45 years to pay the device off that you bought, and you're only going to be in the house for 20 years? And you say to yourself, well, maybe I don't need that dishwasher that's like the extra $1,000 because it just takes way too long to pay off the difference. But that's what this calculation is. There's no new formula for it. It's exactly the same calculation as before. Cost equals power times time times rate. But specifically in these calculations, we're always going to solve for time. So rearrange this formula, and you're not going to find this formula rearranged on the formula sheet. So, I mean, you could memorize that formula. I don't suggest memorizing because then you forget rearranging. And so you're going to substitute in a cost, except the cost isn't like how much you're going to pay. The cost is how much you want to save. And you can sub in any monetary figure you want. Like that's totally open. The goal in these questions is substitute in the money that you would spend initially, and then do a calculation for how long it's going to take to save back that same amount of money. And then it's basically it's free. And then from that point forward, whatever the device is that you bought that's energy efficient, then you actually start making money from that point forward. But the best calculation at first is, where's the break-even point? How long is it going to take? So for example, in question 1, we can't get incandescent bulbs anymore in Canada. They're banned. And this question's probably a little bit old now because most of you probably don't have incandescent bulbs left. But let's say your entire house was still incandescent bulbs and you were looking to replace all of them. So you have two options now. You can buy fluorescent bulbs, which are in the picture there. It's the one in the middle. And now you can buy LED light bulbs as well, which are even less energy, but they're a little bit more expensive than the fluorescent bulbs, which is very strange because they're easier to make. But whatever. So this question here says, you're looking at LED light bulbs and they're $2.50 each. That's a lot. I mean, for one bulb, that's a lot. If you were going to outfit an entire house with LED bulbs, I mean, how many light bulbs are in your house? There's probably 50 at least. There might even be more if you counted every single bulb in your whole house. So let's say you just built a new house. You got to get the electrician to put light bulbs in the entire house, and you're looking at LED light bulbs that are $2.50 each, and you need 50 of them or 100 of them. That's a little bit of a bill, especially if you look at the fluorescent bulbs and they're only $1 each. But here's the question. If you splurged and bought the $2.50 each bulbs, because they're a little bit less power than the 35-watt fluorescent bulbs, how long is it going to take before the cost difference doesn't even matter? Because you're going to save that cost difference on energy. And then from that point forward, just continue saving it. And there's the formula. So there's two different ways you could do this question, and nobody's necessarily going to tell you how to do it. You could substitute in the cost in this question of purchasing a $2.50 bulb. Or you could say to yourself, well, I have to buy the $1 bulb anyway. So if I jump ahead and buy the $2.50 bulb, I really don't have to save $2.50 because I would have had to spend $1 anyway. So maybe you would choose to do this question and say, I need to save $1.50, not $2.50. It depends on how you want to do it. I probably would. I would probably say one way or another, I got to spend $1. If I go extra, I'm going to spend $1.50. So I'd like to save $1.50. And this calculation for one bulb would be exactly the same calculation for 50 bulbs or 100 bulbs, because they would all be saving money at the same time. So I'm just going to do a single calculation here. I want to save $1.50. The rate is the Ontario rate at the time of the question, 14 cents per kilowatt hour. And you need to sub in the power, but here's where you have to be careful. A little bit of a change of just the standard questions from yesterday. You got to make sure to use the difference in power, because that's what you want to do. You want to say, okay, if I'm saving this much power, how long is it going to take that saved power and pay off the extra money that I had to spend? So you wouldn't use the 20-watt LED power, and you wouldn't use the 35-watt fluorescent bulb power. You would say it's a 15-watt difference. So there's the calculation. If I have a 15-watt difference, how long is it going to take to pay off $1.50 extra that I paid? Bump that decimal over 3 times. It's got to be in kilowatts. And that's it. And then run the calculation. The calculation itself will be easy always, once you have the right numbers in there. And just remember from that question yesterday with the water heater, when you get the answer on a calculator, chances are you're never done. Okay, so this comes out to 714.3. And you have to remember, because of the units in this calculation, kilowatts canceling, hours, dollar sign canceling, you're going to get hours. Okay, so the answer is 714.3 hours. But when you do any kind of calculation where you rearrange for time, you're never done. There's always more to the question, because that's going to be the total amount of time if the device was on 24 hours a day, every day. And usually in these questions, there are some stipulations. Like this one says, you don't leave every light on in your house for 24 hours. You don't use them that long. So you don't want to use 24 hours. Let's use an average of 6 hours a day. Some lights in your house are left on a lot. Some of them don't go on at all. Let's take the 6 hours a day sort of average and apply it to this. So you got to save 714 total hours, an average of 6 hours a day. I'm just going to, off the record, without a formula, divide that by 6 because of the 6 hours a day. And that'll put it into, in this calculation, days. So 119 days. Some bulbs would be a lot faster. Some would be a lot slower. But an average of about 119 days, which the question doesn't ask you to do this, but divide that by 30, you're looking at 4 months on average. So that would be the payback. If you spend the extra money for a better light bulb, you're looking at about 4 months of running it on Ontario Hydro prices before the money that you save is going to basically pay the bill that you got charged when you bought the bulb. So 4 months after buying it, it's like you never even bought it. that's the point of these payback calculations, is to show that the little hit in your pocketbook when you're scanning your card at the hardware store or whatever is a temporary fee until you save back the money that you spent. There's 3 practice questions on here, but actually I'm only going to have you do 2. It's going to be really easy because I want to do one together. Let's do the dishwasher question. Question 1. I like this question because I made the question specifically for myself. Like, this was an actual, I was standing in the brick and we were looking at the cheapest dishwasher in the whole place. It was $500. But of course, there's some other appliances in our kitchen that are silver, and this cheap dishwasher was white. So we were looking at the more expensive dishwashers that were silver in color and more energy efficient. And yeah, the really expensive ones, the Bosch dishwashers, they run about $1,100. And that's the problem. We were standing there in the brick, like looking at these dishwashers thinking, do we want to spend $600? Like, that's more than double the price. Do we want to spend $600 extra on an energy efficient dishwasher when the cheap one is only $500? Maybe the cheap one would break sooner and have a not as good of a warranty. But if you set that aside, if you were only talking about the cost, is it worth it? So check this out. Let's do a quick calculation for the payback. I'm not even going to erase the whole board because it's the same formula and the same rearrangement. And remember, you got to think of how to use this formula, because the formula will calculate whatever you want it to calculate. So you got to put numbers in to figure things out the way you want to figure it out. So me standing in the store thinking about this, I didn't want to save $1,100 because we had to buy a dishwasher one way or another. So I was looking at saving $600 because that's the difference. We would have had to buy the 500 one anyway. We were thinking about, is it worth it to jump ahead and buy the $1,100 dishwasher? So I wanted to figure out how long it was going to take to save back the $600 with the energy difference, because really the only way you're saving this money back is the more energy efficient power, but not the entire thing, the difference. So the power in this case is only 400 watts. On the page, it says 1400 watts. But you're going to have the, sorry, it says 1100 watts, but you're going to have a 1400 watt dishwasher plugged in anyway if you buy the cheaper one. So it's all about the savings and the difference in energy if you buy the better one. So 400 watts. Well, remember, it has to be in kilowatts. So you got to shift the decimal over 3 times or divide by 1,000. So 0.4 kilowatts. And just the rate. And that's kind of a reminder when you look at the fact that you're only subbing in these 2 numbers. There's really nothing, there are no time restrictions in this question at all because you're solving for time. So you'll get an answer, but it's going to be the total number of hours that this thing has to be on and in operation to save that money. So 600 divided by 0.4 and divided by 0.14 is 10,714 hours. So that's the calculator answer, but now you got to switch to real life and you got to start thinking about conditions, operational time, and that sort of thing. And there's no formal answers in this case usually. Now it's, you got to kind of work your answer out for your own situation. My dishwasher runs probably 45 minutes on a cycle. But even, let's take it 15 minutes more. Let's say I got it on the pot scrubber setting, which is always like a longer setting that does a better job. Let's say it takes an hour, just for simplicity here. How many times you run a dishwasher? We do it every night, but we have a family of 5 people. Like some of you might only run a dishwasher 3 or 4 times a week. We run it 7 days a week for sure, every single day. So I've got an easy calculation. If I'm running my dishwasher 7 days a week, and I got it on the highest setting where it takes an hour, that's only 7 hours a week that it's going to be in operation. And I got to save 10,714 hours. So in my house, in my calculation, I would divide by 7, and that's going to tell me how many weeks I'm going to be running it. So 10,714 divided by 7, for me, that's 1,531 weeks that it's going to take to pay off the difference. And if I divide that by 52 weeks in a year, that's 29 years. 29 years. There is no dishwasher that's going to last 29 years. Like dishwashers, even the really good ones, you're lucky to get 10, 12, 15 years out of the dishwasher. And that's for the most expensive ones. This is totally not worth it. Like not every payback calculation is worth it. Not every device is worth it. Now, if you are a restaurant owner and you had to buy 5 or 6 dishwashers to put them side by side and you're just running them all the time because dishes are coming back to the kitchen continuously, yeah, sure. But here's, with one quick calculation, here's a device where when you guys are shopping for every single appliance that you need, dishwashers, they don't run enough for you to bother getting the expensive one unless you like the color and it's quieter and it uses less water. I guess there's other reasons why, but if it's specifically because of the energy savings, they'll put advertisements on the dishwasher all excited, energy savings, energy efficient. It's not worth it in this case. The device doesn't run enough to pay itself off fast enough. Get the $500 dishwasher, and then if it breaks 5 or 6 years later and you got to buy another one, buy another $500 dishwasher. Yeah. For what? No, that's what I said. When you get an answer, unless on this I left it vague. I said how long, just so we could have this little discussion about time. But yeah, I mean, if you're doing one of the questions on this page, it'll be more specific. It'll tell you details of the time. But I mean, the ultimate goal here is not to be calculating an answer for a question in high school. The ultimate goal here is to realize that you can do this. Like, this is not outside the scope of you doing a calculation like this when you're shopping as a consumer for things. I did this. And it's not because I'm a physics teacher. It's because I literally wanted to kind of know whether it was worth it. It's an easy calculation. So try 2 of them. There's only 2 questions on this page. We're going to do one of the immediate things you're going to be faced with as a home buyer is your furnace. They're going to do the same thing. They're going to tell you that you could get a mid-efficiency furnace, which is what most people get, or you could go higher and you could get a higher efficiency furnace, which means it runs on a little bit less electricity and it actually pumps out the same amount of heat. So it heats your house virtually the same, but runs on lower energy. And it's about $700 more right now. This was before COVID. It's probably more now, but it's about a $700 addition onto the price of your furnace. And you have to buy everything else. So you'll be stuck in that same situation. You'll be like, do I or don't I? Do I want to spend $700 extra, or do I not have that money right now? Do this calculation and see how long it takes to pay off $700 using the difference in power, and you can see it on the page. The better furnace runs on only 2,000 watts. The regular mid-efficiency furnace runs on 5,000 watts, so you've got a 3,000 watt savings. It mentions $4,000 for the cost of the furnace, but you don't need to save $4,000. You need to save the difference that you would be splurging to buy the better one. So try a calculation for saving $700 with a 3,000 watt difference. But when you get an answer on the calculator, remember, your furnace doesn't run all year long. Your furnace only runs on the cold months. So there's a time restriction at the bottom to work with. And then when you're done, try this question here. I just added this one this morning. I thought it might be worth trying. We were in Costco last night, and I was actually looking at these. They sell a little standalone solar panel. They sell it for people who are camping so that you can plug a device in that you normally run at home, and you can run it off solar power. I thought that was pretty cool, but they're a little bit expensive, $220. They're not bad, though. They put out 300 watts. I thought it was going to be like a very, very low wattage, but that's not that bad. 300 watts you could run some pretty decent devices on 300 watts. So here's the question. Let's pretend, just for the sake of argument, that you did not need this for camping or for going somewhere where it needed to be portable. Let's say that, just for the sake of argument, you bought one of these, you found something in your house that runs on 300 watts, and instead of plugging it into the wall, you plugged it into this solar panel. And let's pretend it's a device that runs all the time, 24 hours a day, all day long, plugged in. Just for the sake of argument, trying it out, how long would it take to save $220? Because if it's a reasonably short amount of time and you can actually think of something that runs on 300 watts that you could do this with, you could buy one of these and argue that it's going to be free, like you never even bought it. Now, there is, of course, one stipulation to this question that I didn't include, and I'm not going to bother including it. It's solar power. So, you're not getting 24 hours a day of sunlight. So the calculation's a little flawed that way. Maybe I should have said like 8 hours a day or something, and I didn't include that. But let's try it. I did it. Again, I'm not being like a physics teacher nerd. I literally pulled out a calculator when I got home because I thought about it afterwards, and I thought, oh, how long would it take? How long would it take to save $220 if you could actually find a useful device to plug into this thing? And if it's a reasonably short payback, maybe it is worth it. I do camp a lot, so I'm actually thinking of going and buying one of these, but I don't really know what to run. Your phone charger is not 300 watts, so it would be overkill to buy one of these to charge your phone while you're camping. And I'm not one of these guys that brings a television camping. No, there are people that do, and that's why they buy these things. That's actually why they sell them. They sell them so you can go camping and like watch the hockey game or UFC using your little solar panel. I guess UFC's on at night. That's not going to work. Unless this comes with a charge pack. Maybe that's what the thing on the right is in the picture. Yeah, that makes sense. You got the solar panel, you got the thing to plug in your device. Charge controller. Yeah, that might be what that is, a little battery. You can actually gain some charge during sunlight hours and then run it later on. Okay, 2 calculations. I'm going to put up answers for these 2, and the answers will match because all the numbers are in those questions. There's nothing you need to look up. So I'll put those up on the post that has this video attached to it. Sorry, I only said that because the video was still recording. I'll put this post up on NCBLE and just 10 minutes from now. You may haven't done yet.
For the question, do we have to minus 300 kind of like do like 120
For what?
for the third one, or will we just use like a
The third one, question 3?
Yeah.
I just,
300?
yeah, question 3 is just question 3, you're not really comparing devices. Question 3 is you either buy it or you walk out of the store and you don't buy it. So I would say use $220 and say, if I did buy it, I spent $220, how long before it would be free? Like I shoplifted into the solar panel and walked out. No, I'm just, how long would it be free? See, but the thing is, people plug stuff in and it's out of sight, out of mind. As soon as you plug in a device, you just don't think about it anymore. And that's the mistake we make. Things in your house cost too much, but they're all plugged in and you get the bill once a month and no one thinks to try to make things a little bit cheaper. And again, it's partly because there is no one thing you can change that's going to be cheaper and make a difference on your bill unless you were to try to change everything. People do this as a hobby, and in fact, I don't know if you know her, she's in grade 12, she's in this class last period, but Gabriella Zapatelli, if you know her father is like that, he's one of the guys in Niagara Falls. That's what he does. Like he's just a, what do you call it, a hobbyist. His hobby is to try and save as much money as he can on his electrical bills, and he doesn't even need to, he's quite wealthy. It's a wealthy family. They own Zappies and they own several real estate properties in Niagara. They've got a lot of money. He does it because he wants to. And his property is out by Chippewa Creek. He's got every energy efficient thing on his property you can think of. It's really cool. He's actually offered to give tours for the class. He's like, yeah, bring your physics class to my property. We'll spend the day. I'll show him all the different devices and things. And he's proud of it. He really likes that he's off the grid. He does not pay a hydro bill now. He's put in so many solar panels, and they're gigantic. He's put in so many solar panels on his property and changed to energy efficiency devices that he now runs his entire house free of Ontario Hydro, which I think is really cool.